keep things simple, we will assume that labor is the only variable input. So, what is the contribution of each additional worker can make the total product? In other words, what is the marginal product of labor to total production? The column 1 in our table shows the number of workers. By employing the first worker, they can now produce 500 units, so total product is 500. The contribution the first worker can make the total product is therefore 500. This is called the marginal product, which we list in column 3. By adding a second worker, total production increased to 1,500 units. The marginal contribution of the second worker is addition to total product is therefore 1,000 units. Now, why is the second worker adding so much more product than the first worker that can produce 500 units? It is because of the benefits of specialization. Before the second employer was employed, worker number 1 will have to do everything from fetching, bending, welding, painting, and everything else in between. But now, 2 workers. The task was divided in between. Specialization takes place. We have better efficiency and the productivity of each worker. Now, if we add third worker, average productivity might increase. Let's say output increase into 3,000. The marginal contribution of the third worker is there 1,500 units. Up to this point, we will see increasing returns with each new worker. Adding fourth worker, which is total product 4,000 units, the marginal product of worker number 4 is 1,000 additional units. As you can see, the marginal product of the fourth worker is less than the marginal product of the third worker. Diminishing returns assessing it. In using more workers in a limited space like this would come inefficient and dangerous. The law says if we keep adding more variable input to the fixed input, a point will be reached what each additional units of a variable input will eventually produce less and less additional output. In our example, this happened when we added a fourth worker. His marginal product of 1,000 units is less than the marginal product of worker 3, which is 1,500 units. Why is that? Additional labor only gets more productive when it has enough space, equipment, and raw materials to work with. But in the short run, it cannot change the amount of space and equipment it has. These inputs are fixed. Only can change is the number of workers. By adding fifth workers still increase in output up to 4,500 units, but the marginal product is now only 500 units. Adding the sixth worker only increased the total product to 4,750 units, so the marginal product of the sixth worker is fell in 250 units. While the factory is producing a little bit more, this increase in output is happening at an ever-diminishing rate. If they keep on adding workers, then eventually reaching the point where the additional worker contributes nothing to production. In our example, this happens when worker number 7 is employed. If they add more and more workers and add number 8, then total production actually stops to decline. In this case, total output dropped into 4,500 units. The marginal contribution of the eighth worker is therefore negative 250. We can illustrate this with the help of a graph. On the horizontal axis, the number of workers is measured, and on the vertical axis is the total output or total product. As more workers were employed, output increases but only up to a point of it to stop to decrease. Drawing a smooth graph of this point, illustrate this adding more of a variable input labor in our case to a fixed input increases total output more and more up to a certain point and then increases output less and less up to it output will stop to fall. Marginal product first increase, It reaches an optimal point and then stops to decrease and finally becomes negative. This is very clear demonstration by the marginal product curve. With this information, we can now calculate the average product for workers, and this will give some measures of productivity. The average product for workers is simply calculated by dividing the total product by the number of workers employed. In the first work, 500 divided 1 is 500. Then 1500 divided by 2 is actually 750, and so on. Looking at average product in graphic form, we see that average product first increases, reaches a maximum, and then decreases. And if we compute total product with marginal product, we can see three definite phases of production. Phase 1 is up until point B. Total product and marginal product both increase. Phase 2 lines between point B and point A. Total product still grows but in a slowly rate. The marginal product labor is getting less and less with each traditional worker, but the total output is still growing a little. Phase 3 is everything of a point A. Total product is now falling and the total marginal product of labor is now actually negative. The general principle of most businesses is that as long as total production is growing, even if it's only slightly, it's fine to keep adding labor in the sure when extra labor doesn't add any more output, that will become a real problem. Exactly way in phase 2, the best position for the firm is will depend on the price of the product and the cost of production.